all my pains and frustrations to you. A bank comparison said no one created a dashboard that shows the daily average balance and how it's been trending across time. So we created this dashboard. This dashboard is actually live and in their environment. Now, why it evolved was initially they said we want to have a calculation of what the year-on-year balance is. So one of my colleagues put this piece of code in. This is the Pandas data frame. And what I'm happy assuming that all of you know Python and all of you know what Pandas is and so on. And if you don't worry, the top will still make sense without any of it. And so we said let's create a column called year-on-year cumulative daily average balance, which is computed based on the year-on-year growth function, which takes the total cumulative daily average balance x and y, some two values, and we computed this particular result. And all was well. Until a few days later, the bank said, no, it's not just this one metric that I want to calculate. I also want to calculate the monthly daily average balance. This cumulative daily average balance was from the beginning of the year. What is the total amount of money the branch has accumulated from the beginning of the year? What is the total amount of money the branch has accumulated from the beginning of the month? And they also said, I want to know the month-end balance. So the developer did the most obvious and logical thing, which is copy-pasted the code and said, CDID, this is the formula. For MDID, this is the formula. And for month-end balance, this is the formula. 2 days later, they came back and said, now see, the one was for all the accounts that were on the balance, but we also want to break it up into the new accounts that came to the bank in the last 2 years, and the old accounts that were not in the bank from before the last 2 years. So now, the developer went into this understand. He copy-pasted the same section of code twice. So this chunk is what we originally had, copy-pasted that, and put in this chunk, except that instead of data, he used total data, and copy-pasted it again, instead of data, he put in ATV data. Perfectly logical. There's nothing wrong with it. Obviously, I'm being sarcastic, right? So, yeah, you can learn this instead to avoid duplication. So the whole thing can be looked through into, so you have 3 data sets, look through all 3 data sets, these are the areas, and you have 3 metrics, so look through all the metrics, and then you can do the computation even by using something as simple as creating a new column name, like if the column name was YOY underscore CDOB, metric anyway moves through CDOB, MDOB, and MEB. So compute that column name, it anyway has a known structure, and compute the column names here also and apply the same function. Firstly, this is smaller. So what that means is that somebody who wants to take in a piece of code has to read only about 7 lines of code, not 39 lines of code. Secondly, it's also more extensible. When the bank comes back with a new area or a new metric, I just have to add one more small entry here, and it's much quicker to develop instead of having to copy paste. Worse yet, this kind of copy paste is okay. The same person is copy pasting from his own code and copy pasting in the same file. The problem starts when other people copying code and putting it into other files. So then we have version issues. So I have a new metric here, I should remember to add it there, except how am I supposed to know where all the people who copy pasted from me? But see, the thing is, at this point, whenever I saw code like on the previous slide, I asked myself, why would any sane person do something like that? Why would you not? Why would you not do? Why would you not use loops? Why would you not use data structures? And it took me a long time, and needing to look at several people to understand something. This guy was not an idiot. In fact, he was borderline brilliant. Okay. And you got a whole bunch of people like that. He put together a whole series called Data Comics. He took Gautam Menon's movies and said, I'm going to analyze the structure of the songs, how long these songs are, what is the mood of those songs, what type of movie is it? Is it a cop or army kind of theme or everything else? Because pretty much half of Gautam Menon's movies are cop themes. And the feel of the song, put it all together in one single visualization. He took football players and said, I'm going to represent the football players not based on what their face looks like, but on their face map what have they won in a World Cup and how many times, what have they won in Golden Ball, Euro, Copa, Olympic medals, so on. And this is what the faces of various famous footballers looks like. It has done this kind of data mapping. All by himself, I mean, totally creative guy. So the problem I realized is not that there are idiots who don't get programming. The problem is that programming is not necessarily intuitive. Copy paste is intuitive. News is not intuitive. And while I say this, at heart I don't believe it, because for me it is intuitive. For some of you it is intuitive. For some of you it is not. And that is a problem because I obviously have to handle a team of let's start with one more example. So this is a dashboard that we built for the Ministry of Petroleum. They said we had a huge problem in 2015 December. In Assam, there was pretty much a mini economic crisis. There was a huge inflation because petroleum stock was significantly low. It was available in surrounding states but not in Assam, and therefore we had to ship it there. And in that time period, the price of almost everything grew up. So we want to avoid these kinds of economic crises by having an information system on where petroleum stock is at any point. We will need to monitor it when it comes down, make sure that people know, etc. And this is pretty big thing because there are 4,000 crores of petroleum stock, and based on our analysis, if they are able to move things around efficiently, then it saves them net at the very least about 42 crores every year. So good. Now this has this particular piece of code. Okay. And now here what we're doing is loading. There is this function called insert L1 file, in which we are reading from a certain file path and then filling the data with blanks. If there's any missing values, fill it with the blanks. And then rename the columns. Basically, if the column name has a new line, then remove it, because the original data was given to us with some column names that have new lines. And then add a column which has the insertion time, which has this particular format, and then there's some other code. Then there's insert L2 file, which takes a bunch of parameters and does the same thing. Read the file, fill the blanks, rename it, insert the time, and an insert key language, which does exactly the same thing. So I have at least 3 functions in which the first 4 lines are exactly the same. Now, in this code, these were not exactly the first 4 lines. They were among the first 5 lines. They were slightly changed, few other things were a little bit messed up, but just by reordering the lines, I could get it to this structure. I said, look, why don't we simply create one common function, which is called load data. And what load data has is the same 4 lines and returns whatever variables you need to, and then just use it. Right? Basic function reuse. And again, this guy is really smart. It's not as if he doesn't know this, but somewhere in the middle of the pressure of all of these things, copy-paste is natural, and copy-paste proliferates. So we're missing this out. This is incidentally the live code that is being deployed, not this one, the previous one. This is the actual live code that is there in the government, and the 27-line code is actually what is there in the back. So it will work, but if somebody has to make a change, then we have a problem. This is another example. This particular piece of code reads 3 data sets. So I have data underscore L1 is it reads from PSU underscore L1, which is a CSV file. Data underscore L2 reads from PSU underscore L2, and data L3 reads from PSU L3. Perfectly logical structure. And then below that we have a condition. If the user says give me information about the L1, which is level 1, then take the last row of L1. If it's L2, then take the last row of L2. If it's L3, take the last row of L3. And this goes on to 12 levels. Is there a better way of doing this? Well, see, the thing is, this is not trivial to replace with a loop or a lookup, because here the variables themselves are different. It's not as if I can say data of L1, because it's not data of L1. Data underscore L1 is completely different from data underscore L2, so we have a bit of a problem, right? Well, see, if the data structure and the variable naming is in your control, then you could do the equivalent of this. You could say, I'm going to have a list L1, L2, L3, and I'm going to look through this and create a data structure. I'm going to create a dictionary where L1 is the result of having read PSU L1. L2 is the result of having read PSU L2, and similarly L3. So now what was data underscore L1 has become data of L1, which means that the if statement simply becomes the result is look up in the data what input you want and take the last row and send it back. Perfectly logical. Table structures are not intuitive, but they are ridiculously powerful. Every time I see an if condition, I squirm, especially if it's an if condition to do with data, because invariably it makes invariably somebody's doing something wrong. If there's an if condition, I know I'm making a mistake, for sure. There's no doubt about it. In fact, I'm going to talk about how we can automatically detect and not correct, but please automatically detect these and tell people that there's something wrong. Code smells effectively. And I hear a lot of these bugs. When you go back and say, look, why don't you just do this? The developer has a perfectly good excuse for why it is not possible in their unique situation. And the situation is always unique. But there is a pattern among those unique situations as well. And there's a solution. The first bug that I get is, my inputs are not consistent. You say, this is fine, you have L1, L2, L3, but my third file is not L3, it is personal. So the file, I have to call it L3 because that's what the user is going to give me as input. Because the web application, the third value is L3, and that's a constraint, you can't change that. But my file name is called POC underscore personal, so I have to put it in if condition. No, you don't. That's what data structures are for. What we can do is have a lookup function. It says L1 maps to this file, L2 maps to this file, L3 maps to a different file. No harm. And then you look through all of those items, and L1 is read from the corresponding file for L1, L2 is read from the corresponding file for L2, and so on, and then you still get the last data set. This solves about 40% of the problems. You say, okay. But to be fair, it's not always obvious to abstract from code. This part was code. It isn't always obvious to abstract from code into data. And the ones in the audience who get this, you need to explain to the others. The ones in the audience that don't get this, you need to learn this. You can abstract from code to data. The other kind of problem is we perform very different operations. So in the personal file, I want to take the first row. But in the other file, I want to take the last row. Why? Oh, because when you given the input, the others are sorted in chronological order, this one is sorted in reverse chronological order. Fine, we can't tell the government how to sort their files, they give us the data the way they want. So rather than changing the government, we can change our code, it's slightly easier. So we then say, I will add one more parameter. So L1, L2 and L3 are no longer just strings that indicate a file, they are actually dictionaries in which you say L1 is picked up from a file called PSU-L1, then PSU-L2, PSU personal. And we also add a parameter called row, in which this, you pick up the last row and the last row from the first two files, but you pick up the first row from the last file. And then, when you actually compare the result, you say, okay, from 0 to look up that particular file type and get the row and pick up that particular element. In other words, the data structure tells you what operation to do. Again, as long as the operation is reasonably consistent, you can perform very different operations across very different kinds of inputs. And then data structures are coming to our rescue. Sometimes I get a poor kind of objection, but the operations are very, very different. In one case, I want to solve the file. In another case, I want to fill the empty values. Now, it's not as if I can just say row equal to 1, row equal to -1 and handle these. These are completely different operations altogether. Well, that's what functions are for. That's what higher order functions are for. So what I can do is have a parameter instead of putting in the row, I say operation is sort values or fill NA or don't do anything. Just return the value as it is. And when we get the result, we compute the operation, look up from the form type what operation it is, and apply that to the data. So you get the result out of it. So at this point, we have ultimate abstractability. In the sense that there's nothing that you can't do with functions that you can do with Python in general. It's all the same code anyway. So now it makes excuses stop. Not headaches begin. People don't necessarily comprehend how to do this. But it's worth practicing doing this. Once you get to the point where you can use a function to delegate all of the different work and keep all the stuff that's common in one place, we've gotten the full power of reusability. We find that it's at this point when we've gotten full reusability, we haven't really gotten full convenience. There's still a long way to go. Specifically, what I find is that people understand data a whole lot better than they understand code. And when moving code into data, we get enormous power. What do I mean by that? Well, see, we have this lookup, right? This lookup is a dictionary in which we have L1, which is a dictionary which has file and row, L2 is another dictionary, and L3 is another dictionary. Now, if it's a dictionary of dictionaries, just put it in the JSON. It's the same thing. This is exactly the same as this, and when I import the JSON library and open this configuration file, this is exactly what I get. Now, the advantage with something like JSON is that it's a data structure that is firstly language independent. If I wanted somebody to write the same code in Java, I'd say, look, here's a JSON file, here's the logic, you implement it however you want, it's portable. A person who does not understand Python will be able to edit my JSON file. Not just that, I can tell the government, look, you use your .NET or whatever system you want, generate this JSON file for me and give it to me. I will then apply the same operations. So now we practically have an API. When moving code into data, we are abstracting it to the point where it is completely completely interoperable and the very least language independent, but for me, even more importantly, much more human understandable. This is not complicated. This is something that many people can understand. But JSON is still something that only technical people understand, and increasingly I prefer YAML over JSON. Simple reason, people forget the commas at the end. People put an extra comma at the end, and parsers are very strict. The JSON standard says no, you should not have a comma right at the end. JavaScript is forgiving, JSON is not. And so the still JSON part of this process have a problem, and with this, should there be a curly bracket, should there not be a curly bracket? YAML is far simpler. No bracket with optional brackets, you don't have to put them in, indentation works. It's also a lot more Pythonic. In fact, this code half reads like Python, right? White space is significant, and also more forgiving parsers and much more power. In fact, YAML is almost a programming language in itself that you can refer to one particular element, you can start modifying these. It's a pretty powerful structure, and all languages have solid YAML parsers, so we just shifted over completely to YAML. In fact, the New York Times did something even more progressive. They said even YAML is too strict. Sometimes the indentation here has to be perfect. You've got to have exactly the same. You could have consistently 2-space indentation, consistently 3-space indentation, that's okay. But it must be consistent. So they created something called RCML, which is a further simplification of YAML, and said even if the indentation is a bit off, it's not enough to figure it out. And they gave it to the journalists and said, no guys, write articles in RCML and we will process it, which is really cool. So we shifted over to YAML and said, let our configurations which drive the code be created in those YAML files. One place where we use this was for a media company. They said, see, we have a need to segment India. Right now, the entire country is divided into 2 regions, Hindi speaking and non-Hindi speaking. And that's how we look at the whole region. But fact remains that several regions, based on their demographic characteristics, are very similar to each other, even if they are geographically very far away. So can we segment these? Can we cluster these? So we built a small application which looks like this. And we took the data for each of the districts. For each district, we looked at what is the demographic characteristics from the census population, people per household, literacy ratio, etc. The religious mix, Hindu population, Muslim population, etc. Asset ownership, how many people have computers, how many people have LPGs, how many people have 4-wheelers, and so on. And then with segmentation, I'm going to skip most of this, pick some algorithm and cluster it. This is running a cluster. What it's doing behind the scenes is applying a clustering algorithm to see which are the regions, but how India should be segmented. And the answer it's come out with is that there should be 6 segments labeled 0 to 5. And one segment is pretty much the UP, Bihar belt, with bits of Rajasthan and Jammu and Kashmir also having similar characteristics, and also in the northeast. And Punjab is a very different beast altogether, completely different demographically. And portions of the northeast are very homogeneous and very different from the rest of the country. Cluster 3, these are the urban regions most likely. So that's Chennai, Bangalore, the Bombay belt, the Delhi belt, the highly urban areas, and so on. And you can then start exploring the features of each of these clusters. So how are they different from one another? So if I were to just quickly summarize what are the most striking characteristics. The most striking characteristics is that cluster 4, which is basically Punjab, has a high Sikh population. Yeah, we know that. And cluster 4 has a high Christian population, that is the northeast region. And if I want to go down defining more characteristics, cluster 4 is also characterized by the fact that it has a relatively lower population in the districts that it's underpopulated. Cluster 3 has low rural population. These are the urban areas primarily. So using an interpretation of the most significant characteristics, you start being able to identify how to characterize these clusters. So we built this application. Now, this application was constructed but applied to this, constructed by programmers, but applied to this scenario by non-programmers. So the entire configuration resides in a YAML file that looks like this. One of our analysts who has never programmed in Python all his life, and not many other programming language unless you consider R a programming language. Sorry about that. And this configuration is what generates the output that you just saw. So what we're doing is abstracting out everything related to where is the data going to come from, what are the columns like, what is the algorithm that needs to be used, etc. to a configuration system that then applies the logic. So which means that the logic abstract, and it can be controlled by data, which is more important. Now, the only problem that this had was that I can't put in functions into that. So, of the earlier examples where I had a lambda, that cannot be in a YAML file. Or can it? Let's try. What does it take to be able to put some Python code in a YAML file and be able to use it? So I want to have an op which says data.sort values of x, which is roughly what I had in Python as well, and foo_na of blank or data in the YAML file, and it should convert itself into this kind of a data structure where it says lambda b.sort values and so on. How do we do this? The good part about Python is that it can compile Python code. So that's how Python works. The Python language has a built-in compiler, and you can use the compiler in compiled Python code if you want to run it, right? So here's a function. Now what I'm going to do is actually run it, show you, and then we'll worry about how this works. And by now I've left at least half of you behind, I hope. If more than half of you understand this, then my talk should have been aimed much higher. But for those of you who don't follow what I'm saying, don't worry about it. It's okay, this is not necessarily intended for you, but while it could be fun. So I'll define this build transform function, and what I'm going to do is say build transform of data plus 1. This returns a function. I'm going to assign this function to a value called add, and say add of 10, that gives me 11, add of 100, and that gives me 101. Let's define data times 2 as the function, and I'll say let's call it double, just not confuse ourselves. So double of the string A doubles A, and double the list A, and that doubles the list A, or double the number 10, or doubles the number 10. It's just executing the same thing, but the important thing is that I did not define double by typing in Python code. I entered a string which could have come from anywhere, and that's what created it. How does this function work? Fairly straightforward. What we do is take an expression and we create a body which is the equivalent of the system typing in the Python for us. So we create a function, define a function called transform, which takes one value called data, and then add another line after that in which series of spaces, and say return an expression. And this expression is nothing but what we passed in as an input. And then we call compile, which tells Python take a string and convert it into byte code. Now this is the compilation part, not the execution part. So the result is the equivalent of what you would find in a PyC file, for example. And we put in some additional parameters such as file name and what is the mode in which it needs to be executed. I honestly don't understand these parameters. I'm just copy pasting code. The context is an empty string, and we execute the code in some context, and what that does is when you execute it, it actually returns the function as if it were typed in the same program, and it comes in as a dictionary element called transform, which I then return. So what we've done is taken a string, put it inside a function, compiled and executed the function, returned the function, and passed it back as an output, which is exactly the same as somebody having typed it. Now you say, wait, why are you doing this? You could have just written the function in the first place, right? Why all this rigmarole? Well, I have two advantages. I know Python, and I'm the author of this piece of software. What if I want to make my software accessible to people for whom neither of these conditions is true? They don't necessarily know Python. They know basic expressions, they know arithmetic and all that, but they don't necessarily know Python. And they are not the people that have the authority to change my software. And when I say authority, even if I provided them the source code, that assumes that they know how to, let's say, clone a Git repo and then make an edit, find the right place, and then make a change there. So instead, for example, I'm going to skip this side. This is an application that we put together called the Data Explorer, which lets you explore data. In fact, let's open the Data Explorer. And what it's showing you right now is the Mumbai Indians teams, this is Chennai Super Kings. Chennai Super Kings performance. Actually, let's just look at all the teams. What I've done is computed in some IPO season, I have no idea which one, the win rate of various teams. So Chennai Super Kings had a pretty good win rate. Out of the 77 matches they played, they won about 58% of them. Indians had a very similar win rate. They played 76 matches and won 43 of those. So that's pretty good. And Delhi Devils played a lot of matches, didn't do so well. And apologies to the Pune Super Giants who never won a single match. But obviously, the more matches you win, the more matches you're likely to play. So it's reasonable that the teams that have won more are also playing more matches. Now I want to know where Chennai Super Kings are winning. So I click on it and find that Chennai Super Kings have played most of their matches in Chepauk in Chennai. Understandable. And they don't have such a good record at Eden Gardens or Wankhede Stadium. On the other hand, if I take Mumbai Indians, they're doing pretty well at Wankhede Stadium. It's their home ground. They're doing extremely well at Chinnaswamy Stadium, but not so well at Savai Man Singh Stadium or Feroz Shah Kotla. So these are the places where they're having issues. Now, this application is constructed purely using a GUI, where in the settings page, you can say, I want to load this particular data set as a file. So just upload that data set, and here is all the data. And I can create a new column in which I define it as whether team 1 equals the winners. So these are the column names, and the way this has been structured is behind the scenes we are putting in, let me just delete this. So it just says enter formula, where the column names are in strings, and you're doing the equivalent of what you saw in build transform, creating a little piece of Python code on the fly that determines what the function should be, returns it, executes it, and computes the result. For example, if I change this to not equal to, trying to do that, but yeah, there you go. Now this would change the definition of wins to losses. Let's save it and submit it, and you find that Chennai Super Kings and Mumbai Indians are doing the worst. I may want to create more complicated metrics. So what I'm doing here is effectively asking the user to type Python, but the user doesn't necessarily need to know that it's Python. Arithmetic is the same in most languages. So they just type in expressions which for all practical purposes look like expressions, and then you can say I will introduce a small subset of a language if you want to do some additional things. If you want to use sorting, then use dot sort. Yes, it's Python, but you don't have to read all of Python. I will just tell you the few things that you commonly use, learn those and apply it. That's possible. That's exactly what we're doing. So before I forget, and just so people don't get confused as to why Chennai Super Kings and Mumbai Indians are always losing, I'll change this data back so that, okay, we have a problem. I suspect this is a caching issue. Okay, I'm not going to debug it now, but I should remember to change this back. So what we've done is effectively taken data and converted it to code, which is what the compilation process does. Can we do the reverse? Can we actually take code and get data out of it? Of course, this begs the question, why would we want to do that? I've seen a number of scenarios where this is useful, and I'd rather go by examples. So the earlier function, build transform, we wanted to test it. Now, how does one write a test case for something like build transform? Well, let's look at what it does. It takes a piece of string and converts it into a function. So the output is a function. I want to check if this function is the same as what it should be. And what it should be is exactly what we built here. So this method that we get is something that should be exactly the same as transform. So how can we check two test cases, check two functions for equality? This is one way of doing it, and I'm going to walk you through bits and pieces of this. I'm importing from those tools something called EQ underscore. All this does is checks if something is equal to something else, and if not, it raises an error. Okay, this is not the secret sauce. We define a function called equal function, which takes two functions a and b, and inside those it gets a code object, and from that it gets something called CO code. Now let's explore these code objects. What exactly are they? I'm going to open Python notebook and say def transform of data that returns data plus 1. That's it. Now transform has an attribute underscore code, which is a code object. Now, this is how Python internally stores all its stuff. This code object can tell me a lot of things about the code. So if I look at dot and put a tab, there's something called an arg count, cell bars, code, cons, file name, blah blah blah. Okay, all of which look potentially interesting. But let's start with name. It tells me that the function name is transform, which is interesting. Which means that if somebody gave me a function to my function, okay, I've written a function, I'm writing a library or a piece of code that other people are going to use. The others are going to pass me a function. If I wanted to know the name name of the function that they are passing, I can still figure it out. In other words, earlier the only thing that we used to be able to do with functions was call them. Now I can figure out more about the function, such as not only the name but also the file name. And in this particular case, it's just an IPython cell, so it tells me that it was in cell 62 of the IPython notebook, not notebook, IPython. Otherwise, it would have told me which file it came from. I can find out what are the variable names that I can pass to it. So I know that it accepts a variable called data, which is useful, because then I can say, look, some of you want to pass me a piece of code in which you want me to call the function as transform of data is equal to something. Some of you want to call it, let's say, file is equal to something. Based on what you're asking for, I will give you different things. So I have one piece of logic which is so abstracted that based on what inputs you're passing me, I will be able to pass you back the right thing or do the right thing without you necessarily explicitly telling me that. In other words, you don't have to say, I want you to pass me data, I want you to pass me file. Just put it as your variable argument. I will read your variable argument and I'll figure it out. Which is exactly what sorry, okay, I've got my sequence wrong. Which is what we did in this particular function. So we wrote a timer function. And this timer function works in a very simple way. I'm going to, like before, copy paste this and then run it and then show you what's happening here. So this, let's import time. So if I say timer of something, it just prints the time since the last time it was called. So let's just say timer of next. So this 7 seconds is the time between the last time I called timer and now. I can put in any code in the middle and see how long it takes. Now, why would I not use a context manager with statement and all that? Because too much work. I just want to say timer at a certain point, timer at another point, and it tells me how much time it's taken in between. Easier. Context managers are cooler, okay, but coolness is not what gets work done. Now, between the last time this was called and now, it has taken 27 seconds. Now, this is fine. We've gotten to the point where it's reasonably simple to use. But the trouble is that I don't want to have to specify next. When I'm debugging, I just want to say timer, timer. And I want it to know where I'm calling the first timer and where I'm calling the next timer. So can it actually figure out which file, which line, which function actually invoked this timer and print that out as a message? So I basically just want to say timer without anything, and it will automatically figure out where I'm calling from and print that appropriately. Now here obviously it's missing a positional argument. So instead, let's do the following. There is an inspect module. The inspect module tells you a lot about code, modules, functions, all compiled Python objects. Here we're creating a function called caller. The caller function returns the caller's function, file name, function and line number. How does it do it? There is a function called inspect.currentFrame. What that gives you is the current stack frame. It basically gives you all the information about where the current piece of code is executing. From there we call inspect of get outer frames. What that gives you is the current stack, its parent, that is all the information about who called it, all the information about who called that, and all the way up to the Python interpreter. So I have the stack. Now what I want is in caller, the current frame is this particular line itself. So we are inside caller. Now this caller I will be calling from some function like timer. So when timer calls caller, it's saying, look, timer, I'm being called by someone, tell me my boss. So my child, you tell me who my father is. So I have to go 2 steps up. So we get all the outer frames and get not 0, which is caller itself, not 1, which is timer. We get 2, which is the context of its parent, the grandparent in this case. And then that has some attributes. Item number 1 happens to be the file. Item number 3 happens to be the function. Item number 2 happens to be the line. And we put this in here and return the information. So what this function does is allows me to not have to use anything. I just say timer and it automatically prints the time and tells me where I'm calling it from. So this is called from line 10, which is here. This is called from line 12, which is here. Both of these were called from IPython input number 74, which is here. We don't need to tell the function what to do. It knows by itself. itself, where we are and the context of what we are asking for. Now this kind of context can make it much simpler to use a whole lot of things. One particular function that we were using was, or one particular pattern we were using was this. A lot of our data was stored in the same directory as code. Yes, that's not a good idea, bear with me, but that's where it was stored. And so we had to, now the thing is, if I want to, let's look at the code first. So what we do is get the folder of the current file. __ file is the current file. We make sure that it's an absolute path, and then we get the directory name. So this is the folder where the current file is residing. The actual file is called data.csv, and it is under this particular folder. So we get the full path of the file, and then the data is just reading the CSV file from this particular path. These three lines are copy pasted into practically every piece of code. So we said no, we shouldn't have to do that. Instead, there should be a file called OpenCSV, for example, which takes the file name, and unfortunately, because __ file is something that varies from file to file, it's something that we have to pass. Therefore, the second parameter source is the equivalent of the __ file. But can we avoid this? A module knows where it is. The function that is being called knows who is calling it and where that file is. So we abstracted it to this. OpenCSV gets, as before, the inspect current frame. From it, it gets the outer frame, specifically the second outer frame, which is basically the grandparent. Now the folder is from this particular one, get the first element, inside that get the first element. Now this isn't as readable or as understandable as if you said dot something dot something. This is where it is because of compatibility with Python 2.7. If you are using more recent versions of Python, there are better functions that will do the same thing, but because I want backward compatibility, I'm sticking to code that is very difficult to understand, with the great comfort that no one other than me is going to read this. Okay. And when I forget, I will kick myself, of course. And then you just say OpenCSV of data.csv from anywhere. It will find out where you are calling from. It will look in that directory and get this data. Now, see, in all of this, the intent was to tell people, don't repeat yourself. You shouldn't have to rewrite code. You should be able to reuse the code. I was doing this every single day to every single person that I met. In other words, I was repeating myself. So we can do better, right? So can we automate these code reviews? Can I tell people to hit themselves on the head instead of me hitting them on the head? Saves me some trouble and probably better for their ego as well. So we had one big problem. Can we actually get the code in one place? Now, if all the code is in one place, you can manage, no issues. So we set up something, and unfortunately not everyone was pushing the code into our GitLab instance. So the GitLab is a private hosted, self-hosted version of GitHub equivalent, and it's brilliant. And then we said, since nobody is pushing stuff into it, let's gamify it. We'll create a leaderboard. We'll tell people how many people have made how many commits on each day. So this is the stats as of yesterday, and each cell represents the total activity on every day. And we will reward them, not for volume of contribution, but for regularity of contribution. So there are 3 of us who are on the leaderboard right now, myself, Joshua and Tejesh, who have been consistently committing on 20 working days out of the last 30 working days. And Sainath, Rajesh, etc., these are doing 19 days and so on. And the total number of total count of activity, how much of it was code, how much of it was issues, notes, and so on. So we have these statistics, and we said, now let's start rewarding people. All the toppers will get awards. And we've been doing this for the last 2 years. It doesn't help. 3 months earlier, we got, sometime ago, we told the managers, look, tell your people to commit it, or else. And there are things to learn from that. Gamification works beautifully at the top. The ones that are really excited about it got even more excited about it. They said, yeah, I want to be the top. So we had to introduce the rules. You can't be the winner success consecutively, and if you won once, then you're not qualified for the next 6 months. I'm permanently disqualified. So and we set up all of those rules, and there are a bunch of winners. So the ones near the top, they're happy. They want to fight, they compete, it's all good. The trouble is that what we are looking for here is not for the top to get better. What we're looking for is for everyone to put in their code, particularly the ones that need help. And if they need help, they're not going to be very happily showing off their code very well. So this is where we had to get processes and rules. Do it or else. So some things work very differently when you want consistency.
That's what I'm done. But finally, we did have all the commits in one location. The GitLab instance had every single piece of code that the entire organization had it. Totally thrilled. And thrilled both because of what GitLab offers and because all the code is in one place. Right? And then started looking at what are the top errors that we find. The number one problem that we had was that encoding was missing when people are opening. We get CSV files that are written in Excel, which has CP125 to encode. You read it with by default use CP125 to encode. But there are a number of files that we get which are often saved as UTF-8. That's a problem. There are a number of files, text files that are given to us as possibly CP125 to read it as read as UTF-8 or vice versa, or there are some of them are UTF-16 files. We've actually gotten Excel files that are UTF-16 files, CSV files that are UTF-16 files, all kinds of formats. And the problems are sometimes because we often get sample data. The sample data doesn't contain any Unicode, it's working fine. And then we put it into production and it goes boom. So we said everybody should always have encoding. Second biggest problem, numbers are printed as 3.1415126595. We don't care what the 15th decimal place is. We barely care what the third decimal place is. So why can't people just print numbers as 3.14? In other words, every time you're displaying something, why are you using just a value? Why aren't you using dot format or percentage formatting? This is the second biggest problem that we had. Magic constants. Lines are littered with V by 86,400. I'm one of the bigger culprits of this one because I know what 86,400 is. Of course, it's a number of seconds in a day. I mean, who doesn't know that? Right? Everyone knows that. And no, not just that. I've also memorized. So this entire presentation was written out of memory. So I actually know the first 30 digits of pi, and I know what the number of seconds in a year, both for a leap year and a non-leap year, and so on. Everybody knows this, right? So yeah, and everybody also knows that the calendar year for this particular bank is not 365 days, but it's actually 364 days. Everybody knows that. When you're writing the code and your client has told you that, yes, of course, everybody knows that. But until that point, you didn't know it either. So label your constants. What are these numbers? Non-vectorization. You saw an example of this earlier. We have a data frame. It supports vectorized operations, but still we write a for loop and go through it. Local variables are assigned but not used. This is a standard Flake 8 issue. We're doing a calculation, we're storing it somewhere, and that's it. Why are you doing the calculation? And this incidentally is often a sign of some other kind of mistake. Either you got old code that you haven't deleted, which is harmless, mostly harmless, other than performance issues, or you actually intended to use it somewhere and haven't, and think that it's fine, but this particular piece of code hasn't been executed in the few times you've tested it, which is really bad. You've imported a module but not used it, same problem. You've initialized a variable, but you've not initialized a variable but are using it. So this code will fail. The fact that it hasn't failed so far means that you just haven't executed that piece of code. So either you remove that piece of code or fix it. You're redefining an unused variable. So you're assigning something to something and then not using it at all, and then assigning something else to the same thing. So why do you create the first one in the first place? Blind except statement. Now you are catching every single kind of error, even syntax errors, and then people wonder why something is not happening. Well, because maybe something went wrong in this section, but because you caught it and didn't raise any warning, it happily ignored it. So what you're getting out is not what you thought you were getting out. Avoid blind excepts. And sometimes we have dictionary keys that are repeated. X is 1 and X is 2. So is X1 or X2? Right? And this is sometimes in static code. Right? We have dictionaries in Python files which are 150 lines long sometimes. They shouldn't be in Python files, they should be in JSON files, but we still have these. And these kinds of errors are obviously good to catch. So how does one catch these? Well, Flake 8 is a good choice. Flake 8 catches about half of these, but it doesn't catch all of these. So we have to actually write a Flake 8 plugin, which gets us to some interesting stuff. What that means is that we can now look at a Python file, understand what people have written using code, and tell them, no, you have done this wrong, change it. Let me give you a sense of how this works. Firstly, a Flake 8 plugin is just a function, and you can call this function with a variety of things. I'm going to confuse you with this. I am going to confuse you, so I'm not going to confuse you. So what you can do is tell Flake 8, here's my plugin, give me the tree of the Python program. Now, what is the tree? The tree is a way in which Python has converted the code that you've written into a data structure. And it's a very parsable data structure. You could convert it into XML or JSON or any such, but internally it stores it in its own way for convenience and efficiency. This is called the abstract syntax tree, and it's a well-defined grammar. Let me show you what that looks like. So first I'm going to take this particular function and run it. Now, no, actually I'm going to save it in a file called test.py. Maybe I already have done that. Yeah, I have a file called test.py in which I have 3 lines. Ignore the comment in the first line. Import 6. Define a function called to_str which takes a value and returns 6.text type of str of val. The terrible function. Don't worry about that. What we're going to do is convert this function into data using the abstract syntax tree. So we say import ast and ast dot parse of, open the file test.py and read it, and that gives us a tree which I'm going to assign to a variable called tree. Given this tree, what can I do with it? Well, turns out the tree is of type module and it has a body which has 2 elements, an import and a function definition. That's correct. There's an import and there's a function definition. What can I learn about the import, which is the first item in this? The import itself has, let's see, I is equal to this, I dot, set of names, which is another list, and I dot column offset, which doesn't really help me, and an I dot line number. And I find I'm stumped. I can't really figure out what I'm importing from, right? Fortunately, the abstract syntax tree library provides a function called dump, which tells me what exactly is happening in here. So this is a class called import in which there's a names attribute which is an alias for the name 6. So I will be able to get this by looking at I dot names dot name of 0. There could be multiple imports that I'm doing in the same line, of which the first import is for 6. So using this, I can do a quick check across all of the projects that I'm running, all of the packages, all of the modules, to see which are the most commonly used modules in our team. We did that. There are some good insights from that. Let's look at the function. So that's let's say b is equal to tree.body of 1. Now this is a function definition. Great. So let's dump it. ast.dump of b. That tells me a lot more. But with this, I'll be able to figure out that it's called to_str. It takes an argument called val, and inside that it's calling a function in which we are taking an attribute of 6 called text type. Inside that we're calling blah blah blah. I'm reading it as if it were code, but that's because I'm so familiar with this particular piece of code that I know what I'm doing. You would probably print it in a more cleaner structure, like something like this, and start arguing about it. So now we can create a function. AST has a function called walk. What that does is walks through every node in the tree. So I can do a for node in ast.walk of tree, print node, and these are all the nodes that are there at various levels of indentation inside the tree. What I'll do then is check if one of these is a function call, then just print it. So let's do that. If it's if is instance of node comma ast.call, then print node. So I have 2 call objects. With this, I'll be able to figure out if somebody is calling str of something. Say, no, that's not a good idea. What you want to use is dot format or percent formatting. Don't call str of something. Don't call Unicode of something. So that can be easily identified this particular way. You can say, give me the function name, print node dot func, and that tells me that the first call. Okay, I am goofing up somewhere. But in the interest of time, this is what you would do to go through that particular piece of code, and this is something we created in a library called Flake8 Grammx, which looks at all of our most common errors. And there are 3 of them. Error 910. Make sure you specify an encoding for a predefined set of functions. Whenever you use any of these functions, just make sure that there is always an encoding against it. Whenever you have a string, use dot format or percentage formatting. Third, if you have a magic constant, a weird number, then make sure that you put it as a variable. Now what do we deem as weird variables? Anything other than this list, or anything other than small numbers, which is up to 10. Half is okay. 12, yeah, that's typically used once in a year, most people know it, and so on. So we went through the most common variables that we find, that people generally understand, and said if people are using these numbers, that's okay, ignore them. Anything other than these numbers, I want you to raise an error and tell people, and if enough people are using it and enough people say yes, we know what this number is, then add it to this
is the opposite of what we did earlier. Earlier, we took text, which was in data, and converted it to code. Now what we have is compiled code. We converted that back to a data structure that we can pass. In fact, we can inspect it and we can also modify it. We've also seen code generation, right? So once you've created it, you can modify it and recompile it to create new code. Now, of course, the people here who are familiar with Lisp will be laughing, saying that, yeah, we had that in the 1970s. That's exactly what macros are all about. Yeah, Python also has it. Sorry about the trouble, but yes, it can roughly do the same thing. So thankfully, with this today, as of 3 months ago, we started an initiative in which the manager said, boss, your code had better be lint free. You should not have flake-it errors or else. And after that, 3 months later, now all of the 27 projects that we have right now, thankfully, are lint free. Bug free is a different story. We'll worry about that later, but at least there are no obvious bugs. What should you take away from this? Firstly, if you see code duplication, consider using loops. That will get rid of things. If you see code duplication, consider using functions. You'll probably be able to put all of the stuff away into a common function. Use parameters to provide variation around the function. But better yet, if you can put your code into data, do that. Data is far more flexible than robust, not flexible. Data is far more robust than code. If possible, keep your data in data files. And I would be very surprised if you can't keep your data in data files. It's almost always possible. Mild preference from my side using YAML over JSON, but the more important principle is code for humans. Construct data structures for humans. Machines can understand a lot of things and they're very efficient. Humans are the bottleneck these days. Simple code can actually be embedded in data. So you don't necessarily need to restrict your data structures to pure data structures. Control structures can actually be embedded. This is dangerous. Don't try it at home, but it's possible. And code itself is a data structure. You can actually abstract code away into a data structure, use it to parse it,